This is question 19 and it's a question involving scale factors, and it says that we've got a regular hexagon that's got sides of length x, which is this smaller one, a, b, c, d, e, f, and it's been enlarged by a scale factor p to give the bigger one. And what we've got to do is show that the shaded region in the diagram is given by this expression. So the first thing I think that we need to do is find what the area of the smaller hexagon is. So this one, and what I'm going to do is I'm going to split it up into triangles. Now each one of these triangles, because it's a regular hexagon, is actually going to be an equilateral triangle. So all the angles are going to be 60 degrees in them. So each one 60 degrees. So just concentrating on one of them here. And because they're equilateral, we also know that all the sides of them are going to be the same. So we know that the side there is going to be x, that side's going to be x, and that side's going to be x. So if I just concentrate on that triangle alone, what I can do is I can use the formula for the area of any triangle. So if we know two sides of it, and this is x and this is x, and we know the angle that's between them, the formula is that the area is equal to half of AB sine C, and that's the way that will be shown in your formulas. So if we try and apply that to the information that we've got that the area is half times, and the A and the B are the sides that's either side of the given angle. So in this case it's x times x, which I can call x squared, and then sine of the angle between, so sine 60. And what we need to do is work out what is sine 60. And it's one of these angles that you may actually know what it is, but you can find it on the calculator anyway. So if I put in sine 60, what I'll get is root 3 over 2. And we can see the form that we've actually asked to find our answer in, as in root 3 over 2, or 3 root 3 over 2. We actually want to keep it in that format rather than converting it into a decimal. So if we do that, we've got half x squared times root 3 over 2, which is the sine 60. And if I bring those together, then I've got root 3 and then times in the 2's on the bottom over 4, and then times x squared. Now, because we've found that, we can see that in this hexagon, we've actually got 6 identical triangles. So that means the area of the small hexagon is going to be equal to 6 times the expression we already had. So 6 times root 3 over 4 times x squared. And I can simplify that by the 6 and the 4, dividing them both by 2. So that will give me 3 root 3 over 2 x squared. So that looks like a good start, because we've got something that looks a bit like that. Now we've got to turn our attention to the bit with the scale factor. So we can see that that's a length scale factor. So what that means is, if the lengths on the original shape, on the smaller hexagon, were all x, the ones on the newer shape are x but times p as well. So these lengths here are x times p. And so that means that the area on the large hexagon is going to be equal to the same thing, 3 root 3 over 2, but instead of x, we've actually got xp squared, because that's the sides of the large hexagon. And then if I just scroll back up, we can see that we're after the shaded region. So the shaded region is just going to be the large area minus the small area. Shaded region is just going to be 3 root 3 over 2, and this is all in a bracket, xp all squared, and then that's going to be minus the 3, so the smaller one, 3 root 3 over 2 x squared. And if I tidy that up a little bit. I can see they've both got a 3 root 3 over 2 in them. So I could take that out as a factor. So I've got 3 root 3 over 2. And then I've got xp all squared minus x squared. So we're just trying to make it look like the thing that's required. So we're trying to make it look like p squared minus 1 times x squared in a bracket there. So if we do that, I can actually keep this at the front, and I'm going to square out that x squared p xp there, square that out. So I'll get x squared p squared minus x squared, and I can see that I've got a common factor there of x squared, so I could take that out and put that outside a bracket. So I'd actually get 3 root 3 over 2 times by taking out the x squared there. So I'm going to write p squared minus 1, and then the x squared that I've taken out I can put there because that's in both parts. And we've done it. So that's as it was required. So I hope that's been helpful to you, and if it has, please consider subscribing to our channel and also giving our video a thumbs up. Thanks for watching.